Alrighty, so today we are going to classify different quadrilaterals on the coordinate plane. Before viewing this lesson, you should be very familiar with the different properties of quadrilaterals, as well as the slope formula, distance formula, and Pythagorean theorem. If you need to pause it on this page before moving forward, please do. All right, so as we get into the coordinate plane, we are going to be asked to prove different things about these various shapes. So let's talk a second about how you would know which tool to use in your toolbox. So first of all, if I asked you to prove that we have congruent sides in a shape, so let's think about a rectangle, for example, has opposite sides being congruent, or a square has all of the sides being congruent. If I wanted to do that, I'm worried about the length and figuring that out. So which is going to do that, distance or slope? If you said distance, you're right. Distance formula helps us figure out how long something is. Notice that I also put Pythagorean theorem there because we've talked about before, Pythagorean theorem does the exact same thing as distance formula and is a little less cumbersome, so we like using it. If I'm talking about parallel sides, I'm no longer worried about the length of those lines. I'm just worried that they never cross or never intersect each other. So how do I figure out if I have parallel sides? Well, we should know that parallel sides always have the same slope when drawn on the coordinate plane. So I want to determine the slope of these pieces. Next, we're coming up with perpendicular. Perpendicular means that the two lines are connecting at a right angle. How could I do this? I'm not concerned how long they are, right? I could have short lines or long lines connected at a right angle. I just need some kind of line segment. So if I'm not concerned about the length, I'm not looking at distance formula. Instead, I'm still looking at slope. And hopefully this is a little review for you, is that perpendicular lines have opposite reciprocal slopes. So something to keep in mind, we're still looking at slope, we're just looking at a different kind of slope. We're back to congruence. Congruent diagonals means the distance across my shape. I want to determine if those are the same length. There you go, keyword length. We're talking about distance. Perpendicular diagonals, do the diagonals cross at a 90-degree angle? Hopefully you're telling me to put it in slope. All right, and last but not least, right angles go in that exact same category, and we're talking about making opposite reciprocal slopes. So I've got a little hint for you guys. How do you keep these separate in your mind? Well, congruent, when we're talking about length, the word congruent starts with a C. Distance starts with the letter D. These are next to each other in the alphabet. So anytime we're trying to find something to do with congruence, we're going to use the distance formula. On the other hand, if I want to find anything that's parallel, perpendicular, or right, those are all closer to S in the alphabet. So give you a little assistance with determining which tool we are going to use. All right, look at this first example with me. It says determine the most specific name for this quadrilateral with the coordinates, and then it lists them. Support your answer mathematically. So let's go ahead and plot those. We have A at 0, 1, B at 2, 4, C at 8, 0, and D at 6, -3. Now, if you're anything like me, I'm looking at those as I plot them, and I'm thinking this is taking shape as a rectangle. If you said rectangle, we're on the same page. So I'm looking at this and I'm like, okay, I've got to figure out, is it a rectangle or not? If it's a rectangle, let's think about some of the properties we know. We know that the opposite sides have to be congruent in order for it to be a rectangle. But the question I have for you, is that enough? If I just show that the opposite sides are congruent, have I specifically shown you that it must be a rectangle? You should be saying no, because another shape that has opposite sides that are congruent is a parallelogram or even a square, right? We just want to show a little bit more to make sure that we lock in that it is in fact a rectangle. But I'm not mad at that idea, so let's go ahead and write that down. We're going to show that the opposite sides are congruent. What else do we have that would actually lock this in? Well, there's more than one right answer. So you get to decide which one you would prefer to do. The second method, after I show that these opposite sides are in fact the same length, is I could show that the diagonals are congruent to each other. This would lock in that it is in fact a rectangle because that's one of the major properties of a rectangle. But maybe I don't want to go there. Maybe instead I'm thinking back to one of the first properties I learned about a rectangle, and I want to show that all of the angles are 90 degrees. So let's say I go that method. I'm like, okay, opposite sides are congruent, but not the same. And all the angles are right angles. So let's add that as our second method for right angles. All right? These are the two things that should prove that it is the rectangle that I believe it is. So how am I going to do this? Well, we just said if I want to show that opposite sides are congruent, I should be using the distance formula or Pythagorean theorem to do that. So that's exactly what I'm going to do. I'm going to jump in here, and I actually prefer to use Pythagorean theorem because it makes it nice and easy. Let's start out with side AB. If I want to figure out how long this is, all I have to do is box it in and make a little baby right triangle where the hypotenuse is the length of the side that I'm trying to find. So I can see that this triangle that I just drew is 3 units tall and 2 units wide. So I'm going to come over here and I'm going to say the length of AB is, now remember Pythagorean theorem, a squared plus b squared equals c squared. I can shortcut this by going ahead and taking the square root to cancel that out. So it's really the square root of 3 squared plus 2 squared. All right, square root of 3 squared plus 2 squared. 3 squared is 9, 2 squared is 4, 9 plus 4 is 13, which gives me approximately, the square root of 13 is 3.61. So that is the length of this first side that I found. This length is 3.61 units long. I'm going to do that for each of my other sides. So now I'm going to find the length of BC by boxing it in, making that my hypotenuse. This is 6 units wide and 4 units tall. So the square root of 6 squared plus 4 squared is about 7.21. The next side that I have, CD, go ahead and box it in. And maybe right away before you start writing anything, you notice that that triangle matches AB above it. I have 2 and 3 as my two sides. Gives me approximately 3.61. And last but not least, AD has a height of 4 and a width of 6. Which still gives me 7.21. So what have we just proven? We've just proven that this side, AB, is congruent to this side, CD, and that BC is congruent to AD. All right. On the other hand, we said right now, that's not enough. That's great, but it could simply just be a parallelogram. So what I have to do is I have to keep going to show that I have opposite sides congruent, but also that I have 4 right angles. Now, how do I show that I have right angles? Well, I'm no longer concerned about the length. Now I'm concerned about the slope. And what kind of slopes am I looking for? I'm looking to see that I have opposite reciprocal slopes. So let's do this. Let's find the slope of AB. Remember, slope, it can just be my rise over my run. We don't have to use the full formula since we have a graph. I went up 3 and over 2. Notice that this line is increasing over time, so it does make sense that my slope is positive. So increasing to be 3 over 2. I want to find the slope of BC. Now, before I do this, I want to be extra careful. Sometimes it's really tempting to say, oh, it's 4 over 6. My rise was 4 and my run was 6. However, if I look at this line as a whole, is this line increasing or decreasing over time? From left to right, it is decreasing. I actually went down 4 and right 6. So if I go down 4 and right 6, the last thing I want to do is ask myself, can I simplify this fraction? And I can. I simplify this and I get negative 2 over 3. Well, noticing what's going on here is really crucial to this. For the first line, I got a slope of 3 over 2, and for the second line, I got a slope of negative 2 over 3. Those are, in fact, opposite reciprocals. So what does that tell us? It tells us there is a right angle between those two line segments. Let's keep going and see if that still happens on the other ones. The slope of CD, again, increasing over time, actually went up 3 and over 2, so a slope of 3/2. And the last one, slope of AD, going down over time, negative 4 over 6, which simplifies to negative 2 over 3. All right, you can see that each consecutive line segment has the opposite reciprocal slope as the line before it, which means there are right angles at every single one of my corners. So is this a rectangle? I think so. So we can say ABCD is a rectangle because the opposite sides are congruent and there are 4 right angles. Sweet! So essentially that's what we'll be doing for each one of these problems. We're going to plot our points and then determine which tools in our toolbox will help us identify each quadrilateral.